All right, so like I mentioned before, today I'm going to be talking about a Greenfield data platform implementation. And basically, the aim and the goal of this was to enable data science on Azure. So before we get started, I want to give you guys a little bit about who I am. I have almost 20 years of experience in the data, primarily in consulting. I've worked in multiple verticals such as financial services, health and life sciences, even media, supply chain, marketing, etc. Um, and I work for Ippon Technologies. As you guys know, this is Ippon. And we're a boutique consulting firm. We specialize in cloud, DevOps, of course, data, and full stack application development. We have expertise across all three major cloud platforms, including AWS, Azure, and GCP. Um, just a few clients that I've worked on. I primarily worked in financial services, so Morgan Stanley, Bridgewater Associates, FINRA, Warner Music, as well as McDonald's. You could ask me about some of my time there. I have lots of stories from every single one of these places. Um, and then finally, just one side note, I have a patent pending kind of submission. I don't know what you call it, but patent pending data quality analysis tool, which I submitted with Morgan Stanley about 5 years ago, 4 years ago. We're still waiting on the result. Apparently it's gonna happen, but we don't know. So let me give you a little bit of background before I actually get started on the work. So the client we actually did this work for is called TickPick. And I know their name is very eccentric, but they're going with that, and they're fully aware of it. So you could actually look at their YouTube channels. They have very, very entertaining YouTube videos. Um, but basically, their premise is they want to be an online marketplace to make sure that they give the upfront customer price to the customer without any hidden fees. So one of their kind of mottos and kind of slogans are no hidden fees or avoid the bees of the hidden fees, right? They've been rapidly growing in the last 3 years, especially from Inc. 5000. They say roughly about a 393% year-over-year growth in the last 3 years. Um, so one of their biggest competitors, as you guys know, is StubHub, Ticketmaster, and things like that. But we've actually done some market analysis, third-party market analysis, and routinely, not always, but routinely, they are the lowest price that's offered across the board. In fact, I've actually procured a promo code for you guys. So if you guys want to leverage it, it's active now. I'm not sure how long it will be active for, but right now it's just use save 10 on your checkout, and you should receive $10 off, I think. I don't know. So what did we actually do here at TickPick? So one of the things that we're trying to do was, of course, increase their revenue. Like they wanted to ensure, okay, we understand that we have this data, like how can we use it and monetize it and change the culture to be a data-driven culture, and to start initiatives based off of data, not based off of my feelings or my whim or someone who's been doing this in the market for years and years. They just have a gut feeling, right? We wanted to back it up with data and actually showcase how our data proves and actually affects the market and how they gain revenue and increase revenue. They've also wanted to understand, okay, what's the best product to push in which markets, and what's the best price for which markets, for which events. For instance, like NFL events, like what's the best marketing campaigns that they could have? What's the best age group so they could target these marketing events to those age groups? And so basically, when we were going to this and they wanted to leverage their data to do this, what we said was, okay, first and foremost, you need to have the capability to look at your data to make informed decisions. You need a platform to kickstart this effort and really build upon this by using data science. So as an overview, this is kind of our timeline or time to market that I like to kind of showcase. We're actually, I'm going to start backwards, but we're actually still on this project and we're actively doing some of the next steps that I list out later on. But, starting from the beginning, we started with an assessment. We said, okay, this is what you have, and we're looking at different angles from their people, process, and technology, and looking at, okay, you need to have this, and that, and we'll talk more about it. I'm not going to just say this and that. And we did an assessment, and we came up with an overview recommendation of future state architecture, as well as an implementation plan. From there, we actually started ingesting data across from their multiple sources, their SaaS providers, their products, and things like that. And we started building things and landing it in the data lake and creating models to actually serve up for BI reporting. By week 10, we had our first production release. And what this meant was we actually started to employ some data science models, especially around customer segmentation. And we started doing a test run on these marketing campaigns. And within the first 2 weeks of us going live, we realized that 3 times our ROAS in our first initial kind of marketing campaigns and our customer segmentation algorithms. And ROAS means return on advertisement spent. Now, this 3x wasn't always 3x, and I'll tell you right now, it's not 3x right now. But our initial rollout was very, very promising that it made us kind of double down and look at other angles where we can look into and increase our return on our advertising spend. Now, so from now on, from week 12 until now, we're looking at different ways to optimize our margins and figure out, okay, is there something that we could gain more revenue by something like surge pricing? If there's a popular event that everyone's looking for, can we gain a little bit more revenue by increasing the price a little bit and increasing the margins there as well? And again, we're still employing different mechanisms and different algorithms to try to figure that out. So now that you guys know a little bit about the overall architecture and kind of how our approach is and timeline, this is one of my favorite blogs that I like to read, and this is Matt Turk. And every year he publishes this massive diagram. And this is pretty large screen right here, and you guys probably can't read any of it, and that's the intent. There's so many different tools and technologies here that I would say that probably 1% of the population knows everything here, especially in the data world. And there's actually about 10 to 15 things that I could personally list, and I don't know all of them, that aren't on this list. So it's like big data, and how do you get even started with understanding, okay, we're building this platform from scratch. Like, do we just get a dartboard and just start shooting darts at it to figure out which tools we use? Because if you look at some of these tools, there's a lot of overlaps. There's a lot of issues to try to integrate them together. There's so many unknowns that when you're trying to build a cohesive system, it's very, very hard to actually undertake. So what was our approach? How did we tackle this massive problem and take it in a very, very kind of logical way? So we looked at basically areas with the biggest ROI. And what we wanted to do was, if you look at all these areas, these are all fundamental pieces of building a data analytics platform. But we wanted to build horizontal slices. So we say from beginning to end, you have this full end-to-end picture of how pipelines are going to happen, how you're going to report it to the end user, how you're going to be able to kind of do analytics on it, and how do you know where exactly your data is. And we did that by, again, looking at the data experience, right? How people are using it from BI. Where is the data going to be stored from a data warehouse? Data orchestration and data movement. How are we getting data from a number of different sources? How are we congregating it together? Data catalog. This was very, very big because anything that's online right now, there's issues with CCPA. That's a new or kind of initiative or regulation that's happened. And any website, if you guys noticed, like within the last 6 months, you have all these new cookie policies, right? All those cookie policies are as a result or a response to CCPA. They want to potentially give more power of the customer data back to the customer. So we needed to know, okay, exactly where our data was, identifying key data elements and understanding how it flew through the system and it went through the system exactly so we could also serve it back to the customer, right? So one of the requirements is, okay, I want to know what data you're keeping about me, show me. So we have to know exactly where it is within our systems. And then finally for data science, and I talked about some of the initiatives there. So by focusing in on those key areas, we also listed out a few of our guiding principles. And this is kind of in conjunction with our client at TickPick. And as part of that, we said, okay, number one is open source first. There are a lot of different things that you could pay for out there, but to be honest, the Apache kind of distribution has a lot of good offerings that you guys should look at first if you're ever looking at anything. So we want to say, okay, let's look at open source first, and let's see what's available to create that baseline. Like this is the free product that's available now. Then what we wanted to do was, okay, typically open source is cloud agnostic, and it usually goes hand in hand. But we wanted to have that opportunity to say, okay, right now their entire ecosystem is on Azure, but if there is a need that warrants it, whatever that need may be, let's make sure that we're building for the end use, not necessarily for the cloud, for the Azure cloud that they're on. We wanted to make sure that if we needed to lift and shift from Azure to AWS or AWS to GCP or what have you, we're able to do that. We wanted to follow the best principles for development. We wanted to streamline it using the best guidelines and the best practices for CI/CD. And then the last three are probably the most important here when we're talking, especially for this particular client, which was we didn't know the scale of how much data we're going to leverage, and especially when it came to things like clickstream, abandoned carts, and things like that. So we wanted to understand what that type of scale was, but at the same time, we wanted to make the infrastructure be able to scale up for that need and scale down when we don't need it. And very similarly, we wanted, this being a startup, and although they're going about 400% year over year, they don't want to spend millions and millions of dollars here. So we wanted to be very, very cost efficient and be able to pay as you go. And then finally, but not least, we wanted to ensure that whatever skill set that were on the team right now, we could repurpose it, leverage it, and build upon it, making sure that we're not introducing something brand new that they have to relearn and study up for. So here's their initial architecture, and a lot of these icons are basically some of their third-party SaaS kind of connections that they're using. Like Ticket Network is actually one of their, I guess, competitors, but they actually get ticket listings from them as well. There's also SeatGeek, which they're also getting a lot of their inventory from. And then, if you can see, if you're familiar with this kind of type of architecture, it's all primarily based around the end user. So their native apps, whether it's in iOS or Android, or their web application, this entire architecture was built around that. They were basically centering everything around a MS SQL database. And they also had a service bus, and they're leveraging that service bus to push out notifications to users, to their CRM tool, which in this case is Iterable, as well as their support ticketing software, which is Zendesk here. Now, the biggest problem with this was they had all these integrations fully streamlined. It was great. There's from their CI/CD standpoint, it's actually following pretty good practices. So there was no major issues with that. The major issues was, how do I leverage that data? How do I actually gain insight from our data? Because understanding, okay, that the application is working fine is one thing, but actually gaining insight from the data is another. So what they were doing was they were actually getting manual exports from Google Ads, from Facebook, from Adjust, doing macros, doing pivot tables. They had templates in Excel where they were cutting and pasting, and then pushing that into Excel reports or Excel graphs, and they're doing this all manual. In fact, when we started there, I think the time to market for a couple of their reports was over a week, and that was just because of pure just manual processes. They've even, at this point in time, they even had Python scripts to automate some of the processes. Now, just because you have Python scripts doesn't mean that it's the best thing out there, right? Python is good, but you need to have that infrastructure, that kind of architecture to actually scale and move it from one thing to another. So this is actually a kind of a high-level overview of the architecture that we ended up proposing and actually, in the end, implementing as well. So as you can see, again, the application is not actually pictured here. Their application is actually one of our sources. So whatever you saw there is still in play for the most part, except for the reporting aspect. So we actually started connecting directly to all these, all their source systems and everywhere that they're pushing or even receiving data from. So we're pulling this data, we're putting this all into Azure Data Lake storage, and then from there we're actually leveraging Snowflake. In addition to Snowflake, we're also leveraging Looker as our BI tool, and then everything else is pretty much using and leveraging kind of the in-house Azure services. On the top of everything, the orchestration, we ended up using Airflow. And again, for monitoring and things like that, we use a combination of Azure as well as Elasticstash or ElkStash. So why did we actually pick these tools? And a lot of times people ask me the question, and it's not just like I mentioned before, it's not putting that big, picture of all the platforms out there and all the tools out there and throwing darts to it. We actually had, some rhyme and reason to this. And I'll walk you through a few of these. So from the business intelligence tool, the key differentiator that we saw for Looker, and especially in the case for TickPick, was the ability to run advanced analytics on it and to actually, once you've modeled the data and put it into a warehouse, it allows for more self-service analytics on top of that. And you don't have to know SQL. You don't have to be really an expert in any of these tools. You just have to kind of look at how the data it presents itself and kind of find different things about it and explore it within the tool. So we like Looker a lot for that. And in fact, we did some presentations alongside the business community, and they actually enjoyed the Looker experience over the other competitors. I won't tell you which competitors they are, because I don't want to make any enemies in the room, but Looker ultimately won here. If you talk about the ELT aspect of it, we ended up doing a combination of Stitch and Python. And one of the reasons why we decided to go with Stitch was our time to market. And one of the rationales behind that is all these, if you look at all these sources on the left-hand side, they're all pretty much SaaS providers, right? So everywhere you look at, it's like, they have APIs, they have ways to connect to get your data. And one of the biggest things, and this actually happened while we're iterating and we're going through our first production release, Facebook, for instance, changed their API. And we found a bug in their API, and we had to do additional analysis on that, and that actually delayed our release to production. So we actually knew about it, it's just we didn't know about it. So that's what happened. So it's nothing to do with Facebook, but just an example. So as part of that, one of the things that we actually ended up doing was we realized that why do we have to pay for the updates to these APIs? If we're paying for a service anyway, let them maintain it and let them update it, and we'll pay pretty much a dirt cheap cost for these services. And when we're looking at different SaaS providers, Stitch actually was the one that connected to everything that we needed. So when we're looking at any of these integrations with Facebook, Google Analytics, Google Ads, as well as Adjust, which is more from a mobile app standpoint, even our Zendesk ticketing and things like that, we just leverage Stitch, and it's just pretty much a point and click, and we got it in our data lake. The next thing is Python. One of the reasons why we're using Python is its ability to, I don't really have to argue Python, but it's very versatile. It also, the staff there was very, very familiar with it. We ended up using Airflow, and Airflow and Python are hand in hand. They're partners in crime. So we really liked the capability of kind of doing everything that we needed in Python, other than the pure ingestion from our source systems. Our data warehouse, we decided to, actually our data lake, we decided on kind of Azure Data Lake storage. So I won't really go into that because that's just innate for Azure. But for our data warehouse, we decided to go with Snowflake. And this was actually a long decision that we were looking into. There's a bunch of alternatives here. But one of the biggest, I guess, value adds is this notion of zero copy cloning. And especially when we're trying to enable these data science teams to run these models with pure production data, we wanted that quick ability to, say, here's production data in your dev environment, do whatever you want with it. And the ability to do that within a matter of seconds, milliseconds even, really stood above all the other kind of providers and other competitors. The other thing is, a lot of these other, data warehouses out there, you have to have like a dedicated DBA or some sort of someone to look at the tables and the structures and things like that. I mean, I'm not trying to boister Snowflake, but they say it's a zero maintenance kind of data warehouse. I wouldn't say zero maintenance, but it's I think their actual slogan is near zero. So it is actually really true. We love actually the fact that when we brought this into production, people who are familiar with SQL was easy to kind of pick it up and they learned it very, very quickly. And we don't have a dedicated DBA, so that's even better. From a data science standpoint, we landed on Databricks, and to me, Databricks is a clear winner here across all the board. But I think the way that the reason why we loved Databricks here in this scenario was this ability to collaborate and its full integration with Azure. I mean, they've partnered up very, very closely with Azure. But I love the way that we start sharing notebooks. Everything is kind of, it accelerates the development, and it also has a potential competitor to Snowflake, which is Delta Lake, and we're able to leverage kind of and easily connect to our data lake without any hoops or whistles, right? So it's just like we spin it up the cluster, and right away we're able to start using a notebook, connecting to our data lake in a matter of minutes, not hours. So Databricks was a pretty clear winner, at least in our environment. And then finally, for data catalog, we ended up going back and forth with this, looking at a variety of different tools, but we ended up with Azure Data Catalog here. Azure Data Catalog, it's free to use, it's dirt cheap, it's $1 per user per month. So very easy to forecast the cost, especially in a place that's a startup. It's but at the same time, you're also able to, you're not gonna get all the bells and whistles. So there's limited functionality, but again, you pay for what you get. So I'm at, yeah.
Your data lake you do with a Gen 1 or Gen 2?
Gen 2.
And then your data does that actually do callers? Does that callers actually catalog the metadata, or?
We built it as part of our release pipeline. So. Version 2. Yeah. No, not data catalog. Oh, did you say catalog?
Yeah, the Gen 2 catalog or Gen 1.
I have to recall. I think it's the first one.
Gen 2 is still private for use.
Yeah, so it's whatever's G8 right now. Okay. That's also another reason, but I'll talk to it right now. One of the things that we're doing is we know that there's new functionalities that are going to come out, and we know that Azure Data Catalog, just like every other managed service, is going to improve over time. So one of the things that one of the lessons learned that we had here was build for today, not for tomorrow. Like granted, we have this grandiose kind of vision for the future. And we want to be like, okay, we want to build, and I was talking with Julia earlier today, was we want to build a Ferrari, right? But, and this is my favorite example, like you want to build a Ferrari, but if you're going to your neighbor's house, why drive your Ferrari 5 feet, right? You could just walk there. So a lot of times what we want to do is we want to make sure that we're focused and we're building for what we actually need, because we know that we can't be satisfied. We need to constantly evolve the product. We need to constantly evolve the platform. So after actually evaluating all of these tools from a cataloging, they're using data science or AI to automatically tag your resources and everything like that. When we looked at it, these platforms and these offerings out there, it's like $150,000, $200,000 a year, right? And they have everything that you need. But the question was, did we need it now or do we need it later? So that's the thing, and that's kind of the rationale that we decided on building for Azure Data Catalog. Our first initiative was changing that mindset at TickPick to make it more of a data-driven and changing that culture there to make it more data-centric and data-driven. So we said, okay, let's instill some of the good principles there by starting off with the data catalog, by understanding, okay, when you're doing a release, start documenting your metadata, by also looking at what are your core data elements and start documenting that. So we wanted to instill good principles there, and knowing that we need to move later on in the future, we wanted to build a product or pick a solution that we could potentially migrate off of if we needed to, and also keep in line the new features that they're going to bring on. Because of course, like I mentioned before, all of their new products and all managed services evolve and they get better over time. So we also wanted to keep an eye out on it. The second actually lesson learned here is actually an interesting one. So there, I'm going to try to describe this as best as I can, but they were using pretty much elastic pool standalone SQL services. The way that I describe on the Azure platform, the elastic pool / standalone versus the managed instance, it's like a less buff or less featured, rich version of the managed instance. Like managed instance equals everything that you get on-prem back in the day. So all the, everything that you need, all the features and functionality is there on the managed instance. Whereas in the standalone or elastic pools, you're missing a few key aspects. Very, very minor functionalities, but one of the functionalities that we wanted to leverage was CDC, otherwise known as change data capture. And the reason why we wanted to do this was we want to start capturing different events and different things about the data, especially when we looked at inventory changes. So how frequently or how fast does certain tickets get sold? And just analyzing, okay, where are they getting sold from? What's our inventory look like? Are they getting sold from outside TickPick or inside TickPick? And we wanted to do some analysis and market analysis there. So at first we were like, okay, let's start looking at what SQL database has, because all of these kind of RDBMSs have the ability to store it in their logs and pretty much log ship it or read from their logs. If it's Oracle, it's condensed logs. If it's here, it actually has a CDC schema and things like that. So why don't we just build it off of what they have available within SQL Server? But when we looked at it and took a step back, we looked at two major things. Number one was cost. And the second thing was we already had this large infrastructure that for every single transaction that occurred, we've already had a service bus and we have already had the application do everything kind of more from an event-driven or microservice-based architecture. So why would we, and this is where when we took a step back, we decided, okay, instead of doing that, let's leverage the service bus, let's leverage the event grid and build upon everything that we've already had rather than starting a new thing, creating a new process that would migrate from a managed instance, elastic pool or standalone instance to a managed instance, and then build in another CDC tool to read from that data. So rather than kind of reinvent the wheel, we kind of piggybacked off of what we already had by leveraging Event Grid and pushing that into our data lake.
Do you challenges with data quality on the events coming across that grid versus what's actually the source?
We always have data quality issues. I think data quality issues, in fact, funny story is about 2 weeks ago, we had a major data quality issue that we're kind of delving into now and trying to figure out now. But a lot of our, I think we're still evolving the platform as we speak. So I would say right now, we're more of in a reactive mode of trying to figure out these data quality issues. So one of the first things that we do is from Event Grid, we put it on our data lake storage. And so then we go back and analyze it and look at it in batches and large processes. One of the reasons also that we're doing that is we don't want to constantly hit our Snowflake instance as well. So keep costs down, we kind of bundle things up and batch things up together. Couple of our kind of data quality issues that we've run into was just the fact that when we're rolling this out, we missed a lot of these transactions. So I think we were missing like an entire weekend at one point in time, and we just didn't know why. And so we're still trying to figure out a lot of these issues, but we're now building in and leveraging kind of Airflow's kind of pre and post processes to be able to actually start building in and integrating our, what we like to call DQM or data quality metrics across the board. So whenever we're pulling data, whenever we're reading from any source and doing any sort of loading or movement of data, we're making sure that we're integrating with our DQM process. The last but final kind of lesson learned here is our managed service versus operational cost. And this is directly synonymous to Airflow. And funny story is, we actually ran into an issue where our guys from TickPick aren't here today, but I was going to point them out. But we actually ran into an issue where there was a lot of memory usage all of a sudden spiking after we did a DAG deployment. So brand new deployment to prod, and then pretty much our Airflow instance started going down, and we didn't know why. And of course, whenever things blow up, it's like the perfect storm. So our folks weren't there, and basically nothing, everything was breaking. So one of the things that we like to say is, we didn't really actually think about how much we had to think about scaling the Airflow and thinking about how much, once we've had this platform, how much time we're investing into making sure that it's up and running, to making sure that it's running efficiently, to making sure that the sizing is correct. And so we're actually, this is part of kind of moving into our next steps, but we're looking at moving our instance of Airflow and kind of our infrastructure of Airflow onto something that's more managed, like Astronomer. Sorry? Yeah, Airflow right now is not, it's Dockerized, but it's not on Kubernetes. We had some issues with AKS, or the AKS, yeah. I get Amazon Azure mixed up sometimes. So when we're talking about like next steps, I already mentioned most of these, but I do want to talk about kind of the new things that we want to look for and we're looking out for. Basically, the three that come to mind right now, I've talked about the managed service and Astronomer, but the three that come to mind right now is really on the Azure front. And like I mentioned before, the managed services from Azure, as well as any other cloud provider, are constantly evolving, constantly getting better. And so the three that are really kind of piquing our interest is Synapse, Personalizer, and ML Service. And in fact, we're actually doing a lot of POCs right now with the Personalizer, as well as the ML Service here, to really kind of cater some of the recommendations that we have, especially when you log in, and you bought a ticket before, maybe you like the New York Giants, or you like, well, I don't know what's the team here, the Redskins, right? Anyway, like depending on your team and your past purchases, we want to recommend things and things like that. Maybe there's a correlation between liking NFL and Broadway or something like that. I don't know, but we're looking into those types of services, and Personalizer is a very easy to use tool. In fact, we got it up and running very, very quickly. The ML service, again, as you could talk to any data scientist, a lot of data scientists don't want to talk about the infrastructure aspect, the DevOps aspect of building models and deploying models. So ML services kind of abstracts that for you with kind of leveraging or simplifying the aspect of Kubeflow and taking that away from you. So we're looking at that as well because we have a dedicated DevOps person on the team, but he's also one of those rare gems that you find in the world where he actually likes DevOps and very, very good at machine learning. So I'm coming from the data side, so I'm not DevOps, so that's the comment. So we're looking at that to expedite our delivery and production of models as well. And Synapse, what Synapse does is it kind of brings everything together. They say that it's the SQL Data Warehouse version 2.0, which it is.